Alright, these ones, same idea as yesterday. The only difference is we're given an initial condition. So once we go through and solve the differential equation, we're going to want to plug in our initial condition and figure out what the constant value is. And then actually write out the original function. So, same thing here. We've got x's and y's mixed up everywhere. We need to separate them. The first thing I'm going to do is pull the dx term over to this side. So, I'm going to subtract it. So e to the negative x squared, y squared minus 1 dy is equal to negative xy dx. All right, I'm going to kind of, so this is going to move to the other side by dividing, and this y is going to move to the other side by, by dividing. So the y will get divided, go under here. The e to the negative x squared will get divided, go under there. So y squared minus 1 over y dy is equal to negative x over e negative x squared dx. Hopefully you followed that. I didn't really show the steps like I did in the last one, but I think you're getting to the point where you might not need that anymore. All right, we can actually write this all a little bit nicer though, so we're going to do that. I'm going to distribute the division of the y. So this is actually going to be y squared over y is just going to be y. Negative 1 over y is negative 1 over y dy. Over here, the e to the negative x squared, because it's negative, I can bump it to the I can bump it to the top and it'll become positive. So this is going to move up. So we're going to have negative x e to the x squared dx. And that's going to work out really nicely for us. All right, let's integrate. So the integral of y minus 1 over y dy is equal to the integral of negative, let's pull the negative out front, negative integral x e to the x squared dx. All right, on the left side, the integral of y is going to be 1/2 y squared. The integral of 1 over y is going to be ln of y. Let's see. Here, the integral of this, we're going to have to get the derivative of the exponent. So the derivative of the exponent is 2x. Well, I only have an x here. So I'm going to put a 2 right here, and I'm going to put it really small. And in order to make that balance, I have to put a 1/2 out here. And now this will work out very nicely. Negative 1/2 e to the x squared plus c. Don't forget our plus c. All right, because if we were to go backwards and differentiate this, we would get 2x. We multiply in 2x here, the 1/2 and the 2 cancel, and that's where we're getting the negative x, just like we had over there. All right, took us a little bit of work, but we were able to do it. So the initial condition, y0 equals 1, what that's telling us is that y is 1, so it's 0, 1 is our ordered pair, and that's what we're going to plug in. So 1/2 times 1 squared minus ln of 1 equals negative 1/2 times e to the 0 plus c. And all these are going to simplify pretty nicely. So 1/2 times 1 squared is just 1/2. The ln of 1 is 0. 1/2 minus 0 equals e to the 0 is 1. So negative 1/2 times 1 is negative 1/2. And then plus c. So 1/2 minus 0 equals negative 1/2 plus c. If you solve this, we're going to get c equals 1. Now that we have that, we know that c equals 1. We can go back up to this original equation. We can plug in 1 for the c. So 1/2 y squared minus ln of y equals negative 1/2 e to the x squared plus 1. There's a lot of fractions in here, so something else that could be done if you want to make this a little bit nicer, we can actually multiply through this equation with a 2. It's going to just kind of neaten up everything. So everything's going to get a times 2. So 1/2 times 2, that's just going to be y squared, minus 2 ln of y. Negative 1/2 times 2 is going to be just negative e to the x squared. And then 1 times 2 is just 2. And so this is an option for an answer. If we want to make this one step further, we could actually bump this 2 onto the y. So y squared minus ln of y squared equals negative e to the x squared plus 2. That would be another option. There's, like I said, there's not really a lot of rules which one is the preferred answer. So you just kind of want to be ready. If you get this, realize that you can switch it into that. Alright, so like I said, it was the same thing as yesterday's lesson, just a few more steps because you have to find the initial condition. So page 378, I have 2 problems for you today, and that's going to be 55 and 57. You are given the initial conditions, so figure out what the constant value would be. Once again, if you have any questions, please send me a message. I will walk you through it. Don't just sit there and not do this. Ask, and we can work through them together. We have so much time right now.